Okay. Page 46. Okay, stopping distance. So this formula will be provided to you, I guess, in your formula sheet, but it is a fairly straightforward formula to understand. If you were driving and all of a sudden you had to brake, the stopping distance would equal to the reaction time that it took you to actually realize to brake, right? Plus the actual braking distance. So by the time you actually press the brake and by the time the car actually stops. Do we understand that firstly from a logical point of view?
Yeah.
Everybody? Yes or?
Yep.
Yeah.
All right. So, for example, if you were traveling a lot faster, if you're traveling 112 kilometers per hour, by the time you react, let's just say if it took this long, by the time you react, it usually your car would have usually been, I guess, would have traveled an extra 21 meters. Let me make that a bit bigger. Would have traveled an extra 21 meters. We can still all see that, right?
Yeah.
Yeah, would have traveled an extra 21 meters, but by the time you applied the brakes, which would have been somewhere here, you would have traveled an extra 75 meters. So in total, by the time you realize to brake and you do actually brake, you have traveled 96 meters when you are driving at 112 kilometers per hour. Does that make sense to everybody?
Yeah.
Okay. This is very easy. This is just following the chart. So if a car is traveling at 80 kilometers per hour, what is the reaction distance? Obviously, 15 meters. What is the braking distance? The braking distance would be 38 meters. What is the total stopping distance? Actual stopping distance for a car traveling at 48? Well, the stopping distance would be 23 meters. 9 plus 14. Any questions there?
No.
I'm going to go some of that. Look, all of these will be easy because you're using the chart. You won't be given a chart in your exams, so I'll leave that with you, C and D, to do for homework. I'll send this on Skype. Let's have a look at question 2. So find the reaction time in seconds, correct to 2 decimal places, for Delilah, who is driving at 38 kilometers per hour and has a reaction time distance of 8 meters before she applies her brakes. So it took her, I guess the distance took her 8 meters for her to realize that she had to react, let's say, and actually apply the brake. So this time we're not finding the distance, we're trying to find the reaction time. Yep.
Yeah.
So the car is driving, and it's going 38 kilometers every 1 hour. Now, you know the distance you've traveled, which is in 8 meters. So you can't, unfortunately, use this 38 kilometers per hour because it's in kilometers. You've got to convert this to meters. There is a trick for kilometers per hour into meters per second, and I will tell you that trick now. And I'll tell you the long way of doing it. If it wasn't meters per second, it had to be, I don't know, meters per minute or something. The trick for converting from kilometers per hour to meters per second would be, if you're traveling at 110 kilometers, you divide by 3.6. So the magic number is 3.6. So if we get our calculators out, and we do 38 divided by 3.6, the answer is about 10.56, I guess, meters per second. Can everybody confirm that they also got that?
Yeah.
Anybody not know what I'm doing here? Okay, fair enough. So that's the trick. But like I said, that trick doesn't work all the time. You need to learn a way of converting 38 kilometers into meters per second, and this would be the math. 38, there's 1,000 meters in a kilometer, so you'll times the top by 1,000. Over 1 hour, there are 3,600 seconds in 1 hour. So, and then if you're going from hours to seconds, you multiply, and kilometers to meters, you also multiply. So if you plug that into your calculator, exactly as you see it, you should get 10.56 as well. Any questions there? Oh, all right. So you can obviously see that every second the car is moving about 10.5 meters. And if your distance was 8 meters, well, how many seconds would that have been? Well, it's obviously less than a second, so we're going to do it like this. It's going to be 8 divided by 10.56.
.757.
Yep. I just want to emphasize something. Did everybody, I just want to have a look at something real quick. And it says correct to 2 decimal places, so my answer would be 0.76 seconds. You agree with that?
Mm-hmm.
Anybody not agree? Okay, this will be the question you'll get in your exam. So this is a style of question you will very likely get. So let's just recap it one more time. We're traveling at 38 kilometers per hour, so the car moves regardless because obviously it's accelerating. And then by the time you realize to react, which is 0.76 of a second, the car would have moved 8 meters. And in this case, we actually want to work out the time, so we converted kilometers per hour to meters per second. Then we would have just divided the distance by the speed it's traveling to get the time. So if you don't remember how to find or how I found this, distance over speed, you can use this formula. If you guys remember that from your science classes, I guess. So time is distance over speed. 8 over 10.56. Okay, let's do this next one. Dexter, who is driving at 97 kilometers per hour, has a reaction of 23 meters before he applies his brakes. What is his reaction time again? So, same thing. We're going to do 97. We can use my trick now. 3.6. Gets me about 26.944 repeater meters per second. And you went for 23 meters, so time equals 23 on 26.94 repeater. 23 divided by answer, I got 0.85. Let me know if that's wrong or if you want me to explain that again. Okay. So I'm just going to keep moving forward until someone tells me stop, all right? Question 3. Stella is driving in a school zone at 35 kilometers per hour. A child runs onto the road 25 meters ahead of her. Okay, keep in mind, the car keeps moving, right, regardless, and by the time you react, the car could potentially reach this child, and that's obviously something that I'm sure they're going to ask to calculate. Her reaction time is 1.2 seconds, and her car's braking distance is 10 meters. Will she collide with the child? Okay, what is stopping distance again? Can someone remind me what the stopping distance must equal to?
Reaction time plus braking distance.
Reaction distance plus braking distance, right? If it was I don't know, stopping time, the stopping time, you would say reaction time plus braking time. You get that?
Yeah.
But if I'm doing stopping distance, you should say reaction distance plus braking distance. Good. Okay. Well, we know the braking distance is what? 10 meters, right? So that's easy. Plus 10. We want to now work out the reaction distance. Well, we know that it took her 1.2 seconds and she's traveling 35 kilometers per hour. So I've got to change that again to meters per second.
Yeah.
So we're going to go 35 divided by 3.6. That's 9.7 to repeater. If you want to work out the distance, again, using this formula up here, distance is equal to speed times time. So if you're trying to work out the distance, it's the speed, 9.72, times the time, which is 1.2 seconds. Hopefully, when we add this with this, it becomes less than 25, and then you can say, therefore, they won't collide. And if it's greater, then unfortunately we have a catastrophe, plus 10. All right, it works out to be 21.67. They will not collide. Any questions there? Alyssa, everything makes sense so far to you?
Yep.
Nice. Kara, same thing, all good? Keeping up?
Yep.
All right. Table shows. Again, I might leave this one. It seems fairly straightforward because I'm giving you the table, so we're going to move past this. That is literally the questions you'll get. So if I show you every single exam paper for the last 4 or 5 years, it's just been these two styles of questions. So I can tell you right now, those are the questions you will get. Just memorize them, maybe keep that in a book. You don't need to learn anything more than that, as long as you're able to convert from kilometers per hour. And I gave you a pretty cool trick there. Divide by 3.6. You can remember that forever. You'll just be able to do these a lot faster without doing the whole math here. Okay, let's move on. These ones are easy, changing the subjects. Blah, blah, blah. We've done plenty of that now. Blood alcohol content. I know we've done that as well now. So I don't really want to do the easy ones. What I would rather do with this estimate, I want to do. Oh, wait. Yeah, I want to do these ones. So this is probably this bit of medication is probably the hardest bit in the formula and equations topic. So let's have a look at some of these questions. Question 3. If I've got 4.5 grams of salt, or if 4.5 grams of salt is dissolved in 75 milliliters of solution, calculate the concentration in grams per mils. Well, that'll be very easy. You just do 4.5 gram over 75 mils. But what if you said grams per liter? Well, the way that would work is 4.5 grams. Now, you've got to ask yourself, how do I get from milliliters to liters? And if you've forgotten that, if you're going from a small unit to a big unit, small, big, you would divide. And if you're going from... Say that again.
Is it divide by 1,000?
It is. So it's going to be 75 divided by 1,000. And that would be exactly how you would write it in your calculator. So the reason why I'm doing it like this is because that's exactly what you would write. So there's still a fraction sign and there's still a division. If we all put that in, we should get 60.
Yeah.
60 grams per liter. And then, of course, same thing, kilograms and liters. Well, let's just assume I had to go from here, from A to C. I'll show you the math for that. That would be 4.5. Again, we need kilograms. You're going from small, which is grams, to kilograms. So small to big, we're going to divide. Grams, kilograms is 1,000. over, again, from milliliters, which would be 75. To get to liters, you'll also divide by 1,000. So plug all of that into your calculator. And we should have 0.06 kilograms per liter. All right. So please try to do your conversions the way I'm showing it here, which is as a fraction. Because a lot of students say, oh, how do you know if sometimes you got to divide or multiply or whatever? If you follow this small and big, then in fact, even when you're dividing, you're still dividing again here. So hopefully you're not getting that mixed up. All right, let's have a look at question 5. In a healthy adult male with a blood volume of 5 liters, the measured blood glucose level was 85 milligrams per deciliter. Is that what you guys learned there? I'm assuming per deciliter. How many grams of glucose are in his blood? Is that DL for deciliter? I don't have it here, but I'm assuming it is.
Yeah, it says in question 4.
Right. Yeah, there you go. So 1 deciliter is 0.1 of a liter. Thanks, Christian. 1 deciliter is 0.1 of a liter. In other words, 1 deciliter is 100 mils. So 1 deciliter is 100 mils. Okay. All right. Where are we? In a healthy, how many grams of glucose? So in a healthy adult male with a blood volume of 5 liters, the measured blood glucose level was 85 milligrams per deciliter. Now, every deciliter is 100 mils. How many deciliters do you have in 5 liters? Well, very easy. You'll just do 5,000 mils, right? Divided by 100 mils. That should get you 50 deciliters. And it's saying it does 85 milligrams per deciliter. That's how I'd read this, per deciliter. And obviously each one is 85. You've got 50 of them. You girls know what you're going to do. And Christian, sorry, 85 times 50. 4,250 grams of glucose are in the blood. Did that make sense?
Yeah.
All right. If deciliters is not in the formula sheet, they'll actually tell you 1 DL equals 0.1 liters. So
I haven't done deciliters before.
Sorry?
I haven't done that in school.
Yeah, perfect. So if it hasn't been done, it's okay. Like I said, they'll give you that actual conversion. I don't like this one, as you can see. I don't like decimals. I just convert it to 100 mils straight away. It's just easier for me to deal with.
Okay.
Makes a lot more sense for me.
Yeah.
Okay. Question 6. Blood alcohol, so BAC, is the amount of alcohol in the bloodstream. We know that. A BAC of 0.05 means the person has 0.05 grams in every 100 mils. So 0.05 grams of alcohol per 100 mils of blood. An average female has 4 liters of blood. Calculate the mass of alcohol in grams present in her bloodstream if she registers a BAC of 0.08. Well, the amount of alcohol is 0.08 grams of alcohol per 100 mils, but she's got 4,000 mils, right, of blood. Divide that by 100. So we're going to go 0.08 grams times 40. And it asks your answer in grams. So the answer is 0.08 times 40. 3.2 grams of alcohol. that she still has present in her blood. Any questions there?
No.
I'm emphasizing these questions. I think everybody can see why. There's 4 lines of work, like 4 lines of a question, and 99% of it is useless. All we needed to know is 0.05 grams of alcohol in every 100 mils, which is standard, and then we're at 0.08, and she's 4 liters, and then we just have to divide accordingly. So don't let the words confuse you. Let's have a look at question 7. A male having a blood volume of 6.18 liters has 2.97 grams of alcohol. If he was tested for drink driving, would he pass? And don't forget, the legal limit is 0.05 grams per 100 mils. Okay, so the first thing I'm going to do is go 2.97 grams, divide that by 6180, so 6180 milliliters, right? Now they'll tell me grams per mil, per 1 mil. So just so you know, let's do it. Divided by 6180. I've got an answer of 0.00048 grams per 1 mil. I need a grams per 100 mils. So what am I going to do to that answer? Times it by 100. I get an answer of 0.048. And even though that rounds up to 5, it's still 48. So technically she would pass. Any questions there?
No.
No.
Okay, done. Question 9. I'll skip 8. You can do that at your own time. A medicinal dose is given as 0.25 milligrams per milliliter. If 5 mils of this medicine is diluted to 100 mils, what is the concentration now? Okay, anyone have any idea on how to do this one? Dose is given as 0.25 milligrams per mil. If 5 mils of this medicine is diluted to 100 mils, what is the concentration now? Yep, any ideas?
Not sure.
Anybody? Or no?
No.
No? All right. So if I've got 5, okay, so again, we understand that the dose that's been given, you're meant to have, I guess, 0.25 milligrams for every mil. If it was at 5 mils, this would be the dosage. You guys understand that? Firstly, so let's just say, I don't know, if you were taking Panadol. If you're taking Panadol and the size was only 5 mils, then the amount of, I guess, the amount of whatever this particular medicine is, you would have had 0.25 milligrams of that within this size. Now it's getting diluted to 100 mils. So the size is increased by 100 divided by 5, which is of course 20. So your new concentration level now is 20 times more than the original case. So this was for a smaller one. Now it's been diluted. So your concentration level has gone up by 0.25 times 20.
5.
20 times 0.25. Yes, 5. Thank you. Okay. So Panadol, let's say Panadol for kids, Panadol for adults. That's the way that works. Okay. Can I move on?
Mm-hmm.
Yep.
These ones are easy as well because you're just following a formula. I mean, Freud's formula, Young's formula, Clark's formula will be given to you, and also using Young's formula, do this and use this and calculate this. Simple stuff. I'm just trying to find something that is a little bit outside. No, all fairly easy, and then you've got a little topic test. Done. That's good. That's equations out of the way. So let's go back. Equations done. Equations done. What I might do, so that you got 2 separate videos, I'm going to stop the recording.